Alright, today we're going to be writing the formula for a sine or a cosine wave. And on Friday you were given the formula and you had to come up with the picture. Well, today we're going to give you the picture and you've got to come up with the formula. So to review, amplitude is this A right here, and we have this new formula, max minus min divided by 2. You're going to like that formula, trust me. We have the frequency, which is how many waves are in 2 pi. And then today we're going to look more at the phase shift, which is movement along the x-axis, and the vertical shift, which is movement along the y-axis. So let's get right into it. And here you have it. There's a picture of a wave. And you have to write the equation for it. And you're going to have to learn how to write it both in cosine and in sine. And up here, I just have the general formula so that we can go through it. So let's start off with the amplitude. That's always the easiest. The amplitude is the high minus the low. And this is why you want to know that formula. Because the amplitude right here is 4 minus 0 divided by 2. So the amplitude is 2. And it's going to be the same for both. Now, it's 2 because this sine wave has been shifted off its rocker, so to speak. We want to be able to draw a line right through the sine wave so that it's balanced, so that our hill and our valley, so our hill and our valley are visible. So we're going to leave that line there, and that's going to help us, and I'm actually going to make it dotted so we don't confuse it with anything. And now we got to figure out my frequency. Well, how many sine waves do I see in 2 pi? Well, that's easy. I see 1. There's my hill and there's my valley. So my frequency is 1. Now, my sine wave normally starts at 0, 0. So I'm just going to come down here and I'm going to take my little smiley face and I'm going to trace this wave, and I'm going to show you that normally we're used to seeing a sine wave down here. And notice the sine wave got shifted. See, the sine wave still starts at 0, 0 right here. But instead, on our red one, it got shifted up. Well, how far did it move? Well, let's see. If the sine wave's supposed to start at 0, 0, this smiley face moved up there. So it got shifted up 2 points. And it didn't get phase shifted anywhere. In other words, my hill is still starting at 0, 0. A phase shift would mean maybe my hill starts over here at pi over 2, but it's not. All right, so we're done for the cosine. The equation of this is y equals 2 sine x, no phase shift, and then the plus 2. Well, now let's write it as a cosine wave. All right, a cosine wave is going to have the same amplitude and the same frequency. We got to look at the shifting now. So I'm going to come over here and I'm going to give myself a cosine wave to look at. And a cosine wave normally starts high, goes down, and I'm going to have to go off the graph on this one because I don't have it. Comes back through and it ends there. So that's what my cosine wave is supposed to look like. So how did this cosine wave get shifted? There's a lot of ways you can look at it. So the easiest way is I always look at the beginning here. And I'm going to move this smiley face till it matches up with my cosine wave again. There, because that's my beginning point. Alright, so how far did this smiley face move from here to here? Well, it moved pi. And again, since I moved pi in the positive direction, this is going to be a negative. But notice my smiley faces here are not matched up with my wave. They moved up. and over. Oh, wait a second. I got to come back here and change this. All right, so to match that up, how far did my smiley faces move? They moved this way, and then they moved up. Ah, so there's my phase shift of pi over 2. And since it's in the positive direction, it's a negative. And then there's my vertical shift. How far did they move up? Now remember, these were starting at 2, and then I moved up 2. So let's say that it moved up 2. Okay, so it's y equals 2 cosine x minus pi over 2 plus 2. Let's check ourselves. That means we're going to take out our calculator. And the first thing we're going to do is we're going to go into mode, and we're going to make sure we're in radians. Perfect. Now we're going to go and we're going to change our window. This window, if I look at my x-axis, it goes from 0 to 2 pi. So this is going to go from 0 to 2 pi. My x scale is still pi over 2. And it looks like my y-axis goes from about, well, let's make it from 0 to 4 because it doesn't dip below 0. So we got 0 to 4. Perfect. Let's clear everything out here and let's type these in. So I think my sine wave should be 2 sine x plus 2. Let's graph it. Are we getting that picture? Let's clean all this up so we can see the picture. Yeah. Do they look alike? Absolutely. All right, here comes the tough part. Let's put that cosine in here. 2 cosine x minus pi divided by 2 plus 2. And I'm going to make this line dark. So if I've done it right, it should draw right on top of my other graph. Excellent! Next one. All right. When you look at this, do you see cosine waves or do you see sine waves? I see cosine waves, so I'm going to work with cosine again first. My amplitude. I like it. I've got a nice, pretty, balanced wave here. I've got an equal amount of hills above and below. So I can cheat and just say my amplitude is 2. All right. Frequency. How many cosine waves do I see? 1, 2. I see 2 cosine waves. And they haven't been moved off their rocker. In other words, I know a cosine wave starts high on the x-axis and then ends high. So I see a perfect balance, right? So I know I haven't been moved left or right. Great, I'm done with my cosine. So my equation, this is y equals 2 cosine 2x. All right, let's do the sine wave now. Well, we always know the amplitude and the frequency is the same, so we got a head start there. Y equals 2 sine 2. Now we got to start thinking about my shift. So I'm going to come over here and I'm going to give myself a sine wave. I know I need 2 sine waves that go too high. So in between here, I'm going to draw my 2 sine waves. So I have the one that goes like this, and then I have the other one that goes like that. Okay, so there it is. So I have to move these smiley faces, I have to shift them so that they're on my cosine wave beautifully. All right, so let's see. Let's move on the vertical. Can we move vertically so that they match right on top of each other? I've got two choices. I can go like that, or I can go backwards. Well, I'm going to go backwards because it's the shortest. So how far did these smiley faces move so that they matched up? Well, let's see. We're going to take this dot, move it. We're going to put it right over there on pi. And now if we move, that dot went from there to there. Okay, how much of a movement was that? Well, that's 90 degrees, and half of 90 degrees is 45. So this thing moved 45 degrees. And it moved 45 degrees in the negative direction, so that means it's going to be plus 45 degrees. All right, let's take out our calculator. Let's check it. All right, I'm going to go to my window. Okay, it's 0 to 2 pi, and my minimum and maximum for my x is going to go, I'm going to make it from -3 to 3. Let's come over here. Let's clear that one out and type in 2 cosine 2x. And down here, this one was going to be 2 sine 2 parentheses x plus pi, whoops, pi divided by 4. All right, let's graph them. There's my first one. That looks just like it. Hey, biscuits! It matches up. All right, got one more to do. All right, so here's my last one. When I look at this, do I see a cosine wave? Or do I see a sine wave? I see a cosine wave. So I'm going to start looking at this as a cosine wave first. Let's find some balance. Here's my balance right here. See, if I draw that line right there, my cosine wave has an equal amount above and an equal amount below. So that means I had a vertical shift going on. Well, my amplitude is 3. 4 minus a -2 divided by 2 gets me 3. And I can see that for my balance. See how I have 1, 2, 3 above and 1, 2, 3 below. That's another way to find your amplitude, by looking for your balance. All right, now how much of a cosine wave do I see? I see a half a cosine wave. Now, my cosine wave always starts high, hits a valley, and then ends high. So I know that this cosine wave has not been shifted off its rocker left or right. However, it has been shifted off up and down, because I had to draw my line not on the x-axis, but up here. So how far up did I have to draw it? +1. So we figure out that this is the equation y equals 3 cosine 1/2 x, and then it had a vertical shift of +1. And let's pull out our calculator here. So 3 cosine 0.5 x plus 1. If we graph it, all right, may have to play with our window a little bit, because we want to start off, we'll make sure we go up there. So let's hit a 5. All right, does that look like mine? Sure, they look exactly alike. Okay, so let's try and get the sine wave now. All right, well, I know it's going to be 3. Amplitude is going to stay the same. Frequency is going to stay the same. Now I got to start looking at my shifting. So let's get a sine wave here to look at. Let's look at a half a sine wave. A half a sine wave that has an amplitude of 3 would look like this. How much was that shifted so that it matches directly onto this? So this is what we're doing. We're taking this and we're moving it backwards. And then we're taking it and we're moving it upwards. And those are our shifts. So let's see. How far did we move along the x-axis? We moved pi. And since we went in the negative direction, it's going to be plus. And then how far did we move up? We moved up 1 whole. So it's going to be plus 1. Okay, let's see. Come over here. Let's make that 3 sine 0.5 parentheses x plus pi in those parentheses plus 1. And again, let's make it dark so we can see if it draws. And come on. Yes, it drew right on top of it. Excellent. Okay. Bye.